Hi everyone, this is Dr. Min San-Soo, a computer science professor at the Southeastern Oklahoma State University. It is an honor and a privilege to have the opportunity to share my computer knowledge in Internet of Things, Raspberry Pi, and the Scratch with your child. In this video, I will give a short introduction and a summary of what we will be covering in each workshop. I will start with a brief introduction of what is Internet of Things, and then what is Raspberry Pi, and what is Scratch. Yeah, so what is Internet of Things, short for IoT? The Internet of Things describe physical objects with sensors, processing ability, and the software and the other technologies that connect and exchange data with other devices and the systems over the internet or other communication networks according to Wikipedia. So what is a Raspberry Pi? The Raspberry Pi is a tiny, affordable computer that you can use to learn programming through fun, practical projects. And what is Scratch? Scratch is a free programming language and the online community where you can create your own interactive stories, games, and animations. And before I get into the list of topics in the workshop, I would like to share some good news with you. You might have heard about the global shortage of chips, including the Raspberry Pi, but then we are able to secure enough Raspberry Pi units for our students. So it is really a blessing. As you can see from the information here, many places they all have the Raspberry Pi units sold out. Even some pre-order has been sold out at all as well. Okay, yeah. All right. So here will be the list of topics I will be covering. And I will start with Scratch. So before I explain what Scratch can do for us, let's watch a video clip to see what is Scratch and what Scratch can do for especially young kids. Okay, yeah. All right, let me play the video.
Searching for interactive programming language on the internet, and I came across Scratch. As soon as I shared my first project, I got instant feedback, and I was like, okay, I want to continue with this.
I remember my first project was a super simple animation. I'm still actually really proud of my first project. It opened my eyes to the different possibilities that coding can present.
So I've been drawing basically since preschool when I learned how to hold a crayon. I think making art with Scratch is different because I can collaborate with other people, make something interactive that other people can use.
There was a song that said, "Happy, happy birthday."
I put Scratch in there. It just became an instant hit on the site and inspired so many people to make their own songs and remixes.
Anyone can do anything with my project, and sometimes it's really funny how they change things at the end. It just goes to show like how much you can actually do with all the things you have from Scratch.
When you're looking at other people's projects, you're engaging on such a different level, which really encourages this kind of mindset of seeing yourself and each other as makers of things and not just consumers.
But I never thought that I could do like the coding part. Like I thought like I have to wait till I'm a grown up and like hire someone to code it for me. But then I was like, hey, I can actually do this myself.
It gets more complex, but once you know the basics, you can add on to your knowledge and move at your own pace.
If you like solving problems, if you like drawing, if you like making music, if you're into anything, Scratch is for you.
I know that in the video, the user interfaces was kind of Scratch version 1 or version 2, but then the reason I played that video is that I believe that it can more related to it can be more related to young kids. Okay, yeah. All right. So now that we know what Scratch is, I will use the this beginner programming language to teach students the basic coding, basic concepts of coding, such as the basic computer inputs and outputs, declare variables, the control structures, such as sequence of instructions, repetition of instructions, or code blocks, and selection. And also, we will touch upon events such as key press, mouse click, sprites, overlapping, other topics such as cloning, broadcast message, and then we will also create many hands-on game projects. Yeah. All right. So here will be the example of basic output and input. Okay. Yeah. And then here will be the input the user can enter from the keyboard, and then the sprite will take that a value stored in a variable, for example, called answer, and then display it is nice to meet you, for example, John, if the user enter John. So this is a very simple interactive program involves output and input. Okay. Yeah, and then we will also learn about control structures such as sequence, repetition. Some people call it looping, using code examples like this. This is sequence of processing. And then this will be the looping, and then we will also use a special feature from the extension called a pen to let sprite draw square or hexagon or a circle. Okay, yeah. Then again, we will create some simple games based on the knowledge we have learned, including the selection. Some people structure, some people call it the condition structure, and then the mouse click event. Yeah, so let me quickly play the video here to share the ideas. Okay, yeah. So this will be the next one. The wizard and the dragon. Okay, yeah. Again, once the wizard is clicked by the mouse button, then you will release the lightning, and once the lightning hit the dragon, then it will display and also say, oops, that hurt. Okay, yeah, so let me demo the game. Okay, yeah, let me click the wizard.
Oops,
lightning is
that
out.
hurt.
Yeah, so let me try it again. Yeah.
Oops, that hurt.
Okay, yeah, let me try it again.
Oops, that hurt.
Yes, I know this is a simple game, but then it will cover the concept of control structures such as sequence, looping, selection, and the events such as mouse click, and the sprite overlapping or touching events. Yeah, and then again this one involve creating new sprites such as dragon and lightning. Okay, yeah, and then with those knowledge the student has possessed, then we can create a more complete game involve counting the points. For example, this is the so-called time to fly game. Okay, yeah. Time to fly. Yeah. So let me again show you the video. Because this game allow us to put all the coding concepts we have learned to create a game. Okay, yeah. So let me show you the game here. Okay, so this will be the game. Okay, yeah. Let me play it. Okay. In this game, you can use the arrow keys to move the sprite up or down, left or right. Okay. And then once the sprite touch the heart, then the point here will be increased by 1, and then everything will animate as well. Okay, so let me show you the game. Okay, yeah. All right, how is top, okay, touch one, and the button touch another one, and you can see that the heart will move around at a different location as well. Okay, yeah. Okay, so okay, it's pretty interesting. Okay, so let me start the game. Okay, yeah. So you can see that it will include playing the song or music as well. Okay, and through a game like this, then again it will reinforce us the concept of creating different characters, also called sprites, or if you want to call it avatar. And then we're going to learn how to make the sprite fly, and then how to switch sprites looks, and then how to make it interactive, and then how to float the clouds, and then how to fly the hearts, and also collect points as well. And with those skills learned, then again then you can create really different games. So you can change sprites using parrots and different food, or change the sprites to stars and dragon, or maybe kind of Superman on this flying carpet. So again it helps us to allow us to use our imagination to create games, and then help us to develop our creativity, and then at the end we can also share our games with other students as well. Okay, yeah. And with those concepts learned, then we will explore the Scratch extensions, which will be different functions such as text to speak, and then or translate. So again, assume that you have some text written already, such as I love you, mom, dad, grandpa, and grandma. Then how do you let the machine to say that sentence for you? Or maybe you want to use the translate block to translate this English sentence into Spanish, and then also that the machine speak that language as well. So how do you do that? So again, let me show you the example here. Okay, yeah. What they can do for us, what the code can do for us. So let me display the sentence such as I love you, mom, dad, grandma, and grandpa first. Okay, yeah, there you go. So you can see that the sprite display the message for us. But then we want the sprite to be able to speak, let a sentence for us as well. So we can attach this one and use the text to speech function to do that. So let me click this play or run button here.
I love you, Mom, Dad, Grandma, and Grandpa.
Okay, pretty neat, right? Okay, pretty neat. So let me clear the message. And then how about we want to use the translate feature? Okay, yeah, translate feature. Okay, there you go. To translate the same sentence into Spanish, and then also display the phrase in Spanish, and also say the phrase or speak the phrase. I should say speak the phrase in Spanish as well. Okay, so I have the code written here already. Okay, let me click the run button. Okay, yeah.
Te amo, mamá, papá, abuela y abuelo.
I assume that that should be correct. Okay, I don't know too much about Spanish. Okay, so let me try another language. Okay, such as, of course, I mean you can try another language if you want to. Okay, yeah. Okay, so that is one example of using the extensions, and then another one will be you can also use the video sensing a code library to create some simple games. Okay, I call it pop the balloon. Okay, so let me show you the example here. Okay, I code get written already. So let me switch to the browser. Okay, so you can see that I have two sets of code, but actually you just need this one. Okay, you just need this one, and then I have removed my sprite cat and added the balloon, and then add the code associated with the balloon. But in order to use this video sensing feature, make sure that you have some webcam ready. Okay, webcam ready. And then usually the video transparency will be set to 50. Okay, all right. And then let me pop the balloon. Okay. You can see that once my hand touches the balloon will produce the pop sound, and then it will relocate itself to a different location and change the color as well. So you can see that this is fun, and then also the code needed is really short. Okay, all right. Now we will spend a few minutes to learn about the Raspberry Pi, which is a powerful but low cost single board computer. And then you can see that the Raspberry Pi allow you to do so many things. And then the key things we'll be using will be the 40 pin, the 40 pin GPIO pins. So GPIO stands for general purpose input output pins. Okay, the connections. And of course, during the course of learning, we will have different virtual IT field trips and the IT professionals who will share with us some of their professional experiences in their fields, and also show us some of their facilities and the working environments. The sense head, the sense head, and then the sense head is an onboard the electronic board, and then we can add it. We can add it on top of the Raspberry Pi, and which is called the Astro Pi by the European Space Agency. Let me show you the picture here. So this is the Astro Pi, and if you look inside this box over here, it will include the Raspberry Pi over here, the extension pins, and then also the sense head. Also the sense head. And then the sense head is equipped with an 8x8 LED matrix display and 6 sensors, including sensors like temperature, humidity, air pressure, gyroscope, along with 2 more sensors. And it also comes with actually come with a joystick, provide you with this up, down, left, right, and push down functions as well. And then again, we will and actually the sense head we will be using. It is the same technology used by the European International Space Station to on the Astro Pi to collect and send data back to Earth. So again, we will then create some physical computing projects using the Scratch coding language to interact with the sense head. We can display the Raspberry Pi symbol. We can display the hello world message on it, and then we can also read and display the temperature or air pressure or humidity along with some other orientation data such as pitch, road, yawn, okay? Yeah, and so the workshop one do not include the example of the IoT application. I will still show this application to students in all the 3 workshops, including workshop 1. So here will be an example of creating the Internet of Things application. Yeah. In addition, for students in workshop 2, workshop 2 and workshop 3, we also spend time learning about Raspberry Pi's 40 GPIO pins and how to use them with electronics such as oops, sorry, my bad, such as the LED or the buzzer, yeah, along with other and electronic such as a switch as well. Yeah. And then we will use Scratch to control those electronics. And then for students in workshop 3, in workshop 3, we will also briefly explore the text-based, text-based language language such as Python, and then make a short comparison with the Scratch, which is a block-based language. What can you do next? Yeah. So again, I really encourage you to explore more. Either get the information from different websites, or maybe get some books to enhance your knowledge. And then once you have those knowledge learned, I mean, all improved, I mean, you can be a game designer. So for example, you can design more advanced games such as this one, the invasion of donuts. So let me quickly play the video. I hope that I have it ready. Yes, yeah. So a short video clip here. Click the play button. Yeah. All right, and then the donuts will show up, and then I can press space bar to get my spaceship hit, and I can use the L key to turn my spaceship around, and then I can press the space bar to release the balls to hit donuts. Sorry, I'm not very good with playing computer games. Yeah. All right, and then of course, I mean, there are more games you can design, such as synchronized swimming, involve the concept of cloning, and then catch the apple, involve the concept of cloning as well. Or many different type of fun games. Yeah. And then, of course, I mean, you can be a system administrator as well. So you can see that the Raspberry Pi really allow you to create so many things, game applications, game server, coding applications, set up a web server, set up a database server, set up a different type of file transfer server or telnet server, or even set up a surveillance system, or create more Internet of Things application. Or you can be a digital artist, or create more STEM IT projects that can help you for future college admissions, or a future career, or just create objects on the side as a hobbies. So let me show you some examples. So again, you can create more games, or you can use your knowledge learned from Raspberry Pi to create some kind of remote car like this with sensors, yeah, and then remote control. Or you can again create a robot if you want to, and then or create some machinery to simulate the real world machine like this one. Yeah, and then the 2 pictures over here, I believe they are created using the Arduino, okay, which is another kind of computer component. But then once you have learned the concept of programming, that will help you to create those pretty cute robots as well. Okay, yeah. So the opportunities are limitless, and I hope that with the knowledge learned from this workshop, we can create a better tomorrow for everyone. Thank you, and I look forward to sharing my knowledge with your child.